Alright, let's get our hands dirty. You've probably heard the term Six Sigma thrown around in boardrooms or on fancy business shows. It sounds complicated, right? Like some kind of secret agent code. But I'm here to tell you it's not. At its core, Six Sigma is a beautifully simple idea. It's a method, a philosophy, a way of looking at a process and saying, we can do this better, way better. It's all about chasing perfection by systematically eliminating defects. Imagine you're building something, anything, a rocket, a chair, a perfect cup of coffee. Six Sigma is the blueprint you use to make sure that almost every single time you do it, the result is flawless. It's about being precise, being consistent, and refusing to accept good enough. So, where does the Six and the Sigma come from? This is where we get to geek out a little with some stats, but stick with me, it's cool. Sigma, or S, is a statistical term for standard deviation, a measure of how spread out your data is. Think of a bell curve, that classic hump-shaped graph. In a perfect world, everything lands at the peak, but in reality, there's always some variation. Most processes run at 2 or 3 sigma. Six Sigma quality is the Mount Everest of process performance. It means about 3.4 defects per million opportunities. That's 99.99966% perfect, like typing all of War and Peace and making only a single typo. So how do you actually do Six Sigma? You don't just wander into a factory and start tinkering. That's a recipe for disaster. No, you need a structured approach, a roadmap. And in Six Sigma, that roadmap is called DMAIC. It's an acronym that stands for Define, Measure, Analyze, Improve, Control. Say it with me, DMAIC. This 5-step cycle is the absolute heart and soul of any Six Sigma project. It's a systematic, scientific method for solving problems. It forces you to stop guessing and start proving. It's the ultimate myth-busting tool. Each phase has a specific job, and you follow them in order, no skipping ahead. Let's break it down. First up is define. Figure out exactly what problem you're trying to solve. Identify the customer and their needs, the failing process, and set a clear, measurable goal. No fuzzy objectives allowed. Next is measure. You can't improve what you don't measure. Collect hard data, establish a baseline, your before picture, and quantify the problem. Then analyze to find root cause, improve to build solutions, and control to sustain the gains. DMAIC isn't one and done. It's a cycle and a way of thinking. Let's put DMAIC into action. We'll start with define and measure and see how they play out in the real world. Imagine a busy hospital. Leadership, led by a Six Sigma black belt, sees patient discharge times are way too long. Patients frustrated, beds not freed, the whole system clogged. In define, they get specific. Reduce average discharge time from 4 hours to 90 minutes within 6 months. The customer is the patient. Critical to quality is getting home on time. They map the discharge process. At a manufacturing plant making high-tech widgets, too many fail final inspection. Green belts help laser focus the define phase. They don't just say reduce defects, they set cut Model X failures from 7% to under 1% over the next quarter. They draft a project charter with scope, team, and expected financial savings. Clarity is the foundation. Without a solid define phase, you're just wandering in the dark. Back at the hospital, measure. No anecdotes. They need cold, hard data. For 2 weeks, they track every discharge. When order written, pharmacy notified, paperwork completed, transport called, and the exact time the patient left. Average is 4.5 hours. Some take over 8. This data is the ammo to prove the problem and track progress. At the factory, they don't just count fails, they categorize each defect with check sheets. Bad solder joint, cracked casing, faulty chip. Across runs, they see what goes wrong and how often. 60% are solder joint issues. Now it's a significant solder problem on line 3. That's a problem you can actually solve. This is where the real detective work begins. The analyze phase takes the mountain of data and tortures it until it confesses. You're looking for clues and root causes, not just treating symptoms, but finding the disease. The hospital team uses a fishbone diagram. The head is excessive discharge time. Ribs are people, process, technology, environment. People, nurses overloaded. Process, sequential signatures. Technology, slow EHR. They list every possibility to organize thinking and miss nothing. At the factory, a Pareto chart shows solder joints are 65% of defects. Cracked casings 15%, the rest tiny. Boom, fix soldering. Why bad solder? Temperature too low? Why low? Controller not calibrated. Why not calibrated? Not on the maintenance schedule. Why not? No one assigned. Lack of a clear maintenance process. The hospital tests fishbone theories and finds strong correlation. Delays spike when pharmacy is backed up. There's the bottleneck. This analysis is thrilling because it replaces opinion with evidence. Now we build. Welcome to the improve phase. Stop admiring the problem and engineer a solution. Develop, test, implement a fix that addresses root causes. Not a bandage, surgery. Pharmacy backup is key. What if there's a discharge pharmacist in peak hours? Pre-printed med info packets? They pilot a discharge cart pre-stocked with common meds and supplies. 1 week trial on one floor, tracked rigorously. Time from order to meds ready drops by an average of 70 minutes. Evidence the solution works. They add a weekly calibration schedule and assign a technician responsible. Install a sensor for real-time temperature with alarm outside acceptable range. Classic poka-yoke, or mistake-proofing. It makes defects from this cause physically impossible. A customer service center with long waits. Define, measure, analyze. 40% of calls are password resets, tying up agents. In Improve, they add an IVR feature. To reset your password using our automated system, press 1. A pilot routes a small percentage to test. 95% of password resets handled by IVR. Agents freed for complex issues. You've done it. Defined, measured, analyzed, implemented. The factory's near perfect, the hospital's faster, the call center efficient. We done? Absolutely not. This is where many projects fail. Control makes sure hard work wasn't for nothing, locking in gains and fencing your new process. The primary tool is the control chart, a time series with upper and lower control limits calculated from your data, showing the natural variation of your improved process. The factory plots daily defect rates. Random points within limits mean stable and in control. A point above the limit signals an immediate change to investigate now. The hospital creates a daily dashboard with a discharge time control chart, reviewed each morning. It visually guarantees the process is followed. They formalize procedures, update the discharge pharmacist job, document the discharge cart SOP, and train all nurses. Documentation ensures new employees learn the improved process from day one. They monitor IVR volumes and success rates automatically, and track average wait times on control charts. First to alert if waits creep up. Control is vigilance with a response plan. What to do when a signal hits, and who investigates. Plans turn firefighting into a calm, controlled, data-driven process. The final step to make improvements permanent. So, after all that work, charting, measuring, meetings, building, controlling, was it worth it? Let's look at the payoff. The benefits aren't small or subtle, they're massive and tangible. Think about our widget factory. Cutting defects from 7% to under 1% saved a fortune. Scrap, rework labor, warranty claims. Every avoided defect goes straight to the bottom line. Waste identified and eliminated. Beyond money, quality, and reliability jump. With a controlled discharge process, patients are less stressed, and transitions home are smoother. Clinicians focus on medicine, and beds free up faster to serve more people. Consistent, reliable products and services build a reputation for excellence. Customers learn they can trust you. Trust you can't buy with advertising. Automated password resets gave faster, convenient self-service. Widgets work right out of the box. Hospital discharge feels efficient and calm. Happy customers are loyal. They come back, spend more, and tell their friends. Six Sigma creates a virtuous cycle where excellence drives delight and growth. Ultimately, Six Sigma is more than a project methodology. It becomes your organization's DNA. Curious, data-driven problem solvers, empowered greenbelts, silos broken. Everyone focused on delivering value, always asking how to do it better. It's a powerful, systematic way to pursue perfection. And even if you never quite reach it, the journey makes your business stronger, leaner, and more successful.